Many ships are fitted with fixed carbon dioxide systems. The aim of these is to extinguish major fires by totally flooding the space with carbon dioxide. For safety reasons, these systems cannot be used in drills. Most seafarers will spend their entire careers without using them. They never become familiar with them. This can lead to ineffective maintenance. And worse, it often means when they are needed, they're used incorrectly or their use is delayed. The result is danger to personnel and damage to the ship. An engine room fire broke out on a tug towing a rig. At the time, the engine room was believed to be unmanned. The carbon dioxide system panel was opened. The alarm sounded and the engine room ventilation shut down. It took some time to confirm that an engineering specialist on board was not in the engine room. After this delay, it was decided to use the carbon dioxide system. In the stress of the situation, the officer ordered to operate it forgot the instructions. He believed he was looking at an operating system with a backup. He only operated the first lever. Hours later, he realized he had not operated the system correctly. He decided to check the carbon dioxide room. It was obvious that no carbon dioxide had actually reached the engine room. By then, the fire had burnt itself out, completely destroying the engine room. It's vital for officers to be familiar with the carbon dioxide installations on their ship. During a major emergency is the wrong time to work out how to use the system. Officers will be faced with demanding decisions. They must educate themselves about their system before they have to use it. If the engine room is on fire and unmanned, the carbon dioxide should be used as soon as possible. There is no benefit in delaying. Fire teams should only be sent into a burning engine room if there are personnel inside. Delaying using the system only increases the damage to the engine room or cargo space and increases the risk to the ship and the personnel on board. Carbon dioxide makes up a tiny proportion of the atmosphere, less than 1/10 of 1%. At higher concentrations, it doesn't just asphyxiate, it's toxic. It affects the central nervous system. These effects begin at a concentration of 2%, which after an hour or two causes headaches and difficulty breathing. A concentration of 5% causes headaches, difficult breathing and sweating after a few minutes. 10% quickly causes unconsciousness or near unconsciousness, increased heart rate, headache, sweating and rapid breathing. At concentrations higher than 17%, the result is loss of control, unconsciousness, convulsions, coma and death. In dealing with carbon dioxide systems, remember that the hazard is much greater than asphyxiation by an inert gas. Although all systems will be different, they will have similar components. These will include a number of gas bottles, a manifold linking them all, and a release system involving a main release valve. The release system will always be operated by small gas bottles, as these systems are designed to operate without electrical power. There are always two operating systems, one in the carbon dioxide room and a remote one outside it but not in the engine room. Two officers should be involved in releasing the carbon dioxide. Generally, the master instructs a senior officer to release the gas. This officer is accompanied by another officer to carry out the actual operation. Usually, the general alarm will be sounding. Opening the cabinet usually sounds the carbon dioxide general alarm in the engine room. It also turns off the engine room ventilation and closes the fire flaps. As there's usually only enough carbon dioxide for one shot, there's no point putting it into a fully ventilated space. If these actions are not automatic, then the operator will need to stop the ventilation and close the flaps. Then wait for 10 seconds before releasing the carbon dioxide. Many systems are fitted with a built-in delay to allow the ventilation to stop before the gas is released. Some ships also have systems for flooding the cargo holds. Officers need to be certain they know how to select the right hold and the appropriate number of gas bottles. Activating this system requires the operation of two separate levers. The first supplies pressure to the cylinders. In the carbon dioxide room, the first handle also goes down. This opens up the valves in the cylinders, so pressurizing the manifold. The indicator on the last bottle in the system operates. Inside every cylinder, there is a spring-operated valve. It opens when pressure is applied, releasing the carbon dioxide. The second lever is pulled down. This operates the second lever in the carbon dioxide room, causing the main release valve to open. The gas travels from the manifold into the pipework that takes it to the required space. Once the system has been operated, the next step is to visit the carbon dioxide room to check that the gas has been released. This must be done wearing full breathing apparatus, as even a small leak can raise the concentration of carbon dioxide to dangerous levels. There are a number of things to check. First, has the main valve opened? If it has, it's almost certain that the gas has been released. Secondly, have the tallies on the gas cylinders blown? This is a useful double check. There are two secondary checks. There should be ice on the pipes leading from the cylinders to the manifold. And finally, there should be no pressure on the manifold. If all these indicators show that the gas has released, there's just one more thing to do. It's worth opening the valves on all the gas bottles, as there will still be some carbon dioxide in them. Because it is likely that the internal valve will have closed the cylinder before all the gas has gone. Opening all the valves might take some time if there are a lot of cylinders. If the carbon dioxide has not been released, it should immediately be manually released, using the system in the carbon dioxide room. Finally, the space that has been filled with carbon dioxide must be left for 24 hours before any entry is attempted. Always check the temperature of the space before entry. A suitable thermometer, such as a laser thermometer, should be kept outside the engine room for this purpose. Even then, the space must be thoroughly ventilated before entry, and the carbon dioxide level checked. As carbon dioxide is heavier than air, great care must be taken in the first few hours after entry, as there still might be pockets of the gas remaining. Flooding the engine room with carbon dioxide will stop the engine and leave the ship without power. A major engine room fire would do the same. The ship will then drift. The anchor should be lowered as soon as the ship reaches a depth of water where it will be effective. The master will remain on the bridge and should train personnel about their role in an emergency.
Your responsibility is to maintain communication with the crew.
Communication with coastal authorities, nearby ships, and the operator should be started before the carbon dioxide is released. The ship will need help and advice. Routine maintenance of the system is the responsibility of the engineers. Usually, there will be a monthly check of the system. The gas bottles must be checked at least once a year. Before maintaining this system, the chief engineer should consider the risks. It's worth thinking about blanking off the system while it is being maintained. This may mean establishing a temporary fire watch. It has become standard procedure to blank off the system during dry dock to minimise the risk of accidental release. In each situation, the engineering department needs to consider the risks and manage them. Make sure you understand your fixed carbon dioxide system and how to use it. Be prepared to use it early in an emergency. There's nothing to be gained by delaying. You should only send fire teams into the space where the fire is burning if you know personnel are inside. Immediately after operation, check that the gas has been released to the correct compartment. You must always wear breathing apparatus to do this. Always take great care in maintaining your carbon dioxide system. You might need it one day.